In this problem, we will be looking at rewriting and interpreting functions. In this problem, Darnell opens a savings account that compounds interest every 2 years. The function below represents the amount of money in his savings account after t years. So, C is the correct statement, and I'm going to walk us through how we got to that answer. So, we know at the beginning of the problem that we have 2 years, so this is for every 2 years. So now in the equation for solving compoundly, we want to know how it is for a singular year. So we're going to look at this. T. And we'll say that's AT equals that equation. So that's essentially the basic equation for this compounding interest over a single year. So now we know that in our equation that we have, it has t over 2. So now we ask ourselves, what do we do about finding that next step? How do we get that from t over 2 to just t? So a strategy that I've used and that I recommend you to use is to use the square root. So I'm going to write some numbers out here. Bear with me. So this first is essentially the original equation. Then we're going to be breaking it down. 1,000, 1, 3, 4. And you see here, I'm going to actually edit and put a t over 2, a 1 over 2 here. So that's excuse me, I'll scratch that. So that's 1,000 to the 1/2, or the square root to the t. So now, as you continue on, that 1,000 is going to be multiplied by 1.0067 to the t. And so that right there is the formula for the compound interest over these next few years. So now we know that we can do 1,000 times 1 plus 0.006, and that's the final equation broken down into there. So how do we know that it's that 60.67% increase each year? And it's because of this value here, because when you take that R value out and you multiply that value times 100, gives you 0.67%.